This example gives us parametric equations of some two lines and asks us to show that these two lines intersect and find an equation of the plane that contains the two lines. Well, first thing first, when we actually have lines in 3 dimensions, it is actually quite possible that we can have lines that are not parallel and do not intersect each other. Like for example, if I have the z-axis here, and I have another line that is parallel to the y-axis. These two lines, they are not parallel, but they will not intersect to each other. So, for this problem, we need to show that these two lines intersect. Let me kind of try to draw the picture here. So I have kind of some funky two lines that intersect at some point. So, to show that the two lines intersect, that means I need to show that there is this straight point. There is a point that lies both on the first line and the second line. In other words, I'm gonna need the x-coordinate for the first line and the second line to be equal. I'm gonna need the y-coordinate of the first line and the second line to be equal, and then I'm gonna need the z-coordinate of the first line and the second line to be equal. So, however, I'm actually gonna have to change one of the variable to other name, because the t is not necessarily that the t in the first equation is equal to the t in the other equation. So, if I were to write this guy into 3 equations, I'm gonna get that the equation that I need to solve is the x-coordinate has to be equal. So let me change the t's in the the parametric equations below to the s. So it's gonna be 12s minus 13. And then, let me see, t plus 3 equal to 6s plus 1. And then 1 is gonna just equal to 3s plus 2. Another way you can think of this system of equations is that you can think of this guy as a vector form. So in vector form, this would be 4t minus 1, and then t plus 3, and then 1. The other guy, I changed this to an s, so that would be 12s minus 13, 12s minus 13, and then 6s plus 1, and then finally 3s plus 2. Well, I need these 2 points to be equal, so I'm going to need to set them to be equal. And for the two points to be equal, they have to be equal in every coordinate. So this guy equal to this guy, which is what we have here. This guy equal to this guy, which is what we have here. And then this guy equal to this guy. And that's the last equation we have. So, let me actually just solve this guy for you. The t and the s that we are going to get is my t is just going to equal to negative 4. And then my s is going to equal to negative 1/3. Now then, if I plug the t and the s into these equations, we are going to see that the x-coordinate, this guy, is going to equal to, let's see, negative 17. If I plug t and s into this guy, I'm going to see that my y-coordinate is going to equal to, let's see, negative 1. And if I plug this t and the same t and s into this guy, my z-coordinate is going to equal to just 1. So that's the value of this guy. In other words, the coordinate of this red point, the coordinate of the intersection point, is going to be negative 17, and then negative 1, and then 1. Okay? So now the first part is done. These two lines indeed intersect. And now I'm gonna need to find an equation of the plane that contains these two lines. You can kind of imagine, if I have two lines intersect at a point, there is a plane that is going to contain this two lines. So, let me actually show 2 ways to actually do this. The first way is that I can do the parametric equation of this plane. Because I already have the point that this plane is going to go through, if I can find the vector that is parallel to the two lines that the question gave me, then I can use that to find the parametric equation of this line here. And lucky for us, this two vector is not that hard to find. So, if I were to write this guy in vector form, that would just be, well, I can actually do it from here, or I'll do it from here. That would just be t times 4 and 1 and 0 plus -1 and 3 and 1. So that means a vector that is parallel to this line is going to be 4, 1, and 0. So I have that this plane contains this little orange vector here, whose coordinate is 4 and 1 and 0. I do the same with the other guy. The vector form for this, okay, I'm running out of place to write. The vector form for this second equation, for the second parametric equation for line is going to be t times 12 and then 6 and then 3 plus -13 and then 1 and then 2. Okay, so a vector that is parallel to this line is going to be 12 and 6 and 3. Let me actually kind of scale this down to 4 and 2 and 1 because it's just a scale of this vector. So I now have a parametric equation of this line that the question wants. It's going to be just this point. Let me write it down here, which is -17 and then -1 and 1 plus the first vector 4, 1, 0 times something plus the second vector 4, 2, 1 times something. So this is my equation of the plane in vector value parametric form. Now then, let me actually find this in the regular equation form. Now to do that, let me actually find the normal vector to this plane. So the normal vector is going to be the vector that is perpendicular to this plane. And I'm going to find this purple vector by computing the cross product of these two guys here. The cross product of these two guys is going to be, let me write this down. That's going to be, let's see, 4, 1, 0, and then 4, 2, 1, and then ijk. I compute the determinant of this guy. And that is going to be, let's see, it's going to be -I. And then, let me see. It's going to be -4j. And then for the k, I'm going to have +8 minus 4. So that's going to be +4k. So my normal vector is going to be, wait a minute, something is not right. This should have been +I. So this is just the regular I. Okay. So the normal vector to this plane is going to be 1, -4, and 4. So now I can conclude that the equation for this plane is going to be 1 times x minus the x coordinate here, which is going to be x plus 17, plus -4 times y minus the y coordinate here. So it's going to be the y coordinate of my red point. Y minus -1, so that's going to be y plus 1, plus 4 times z minus 1 equals to 0. So this is also another equation of the same plane. If you were to simplify this guy, that would give me x minus 4y plus 4c equal to -25. Wait a minute, not -25, I mean -9.